All right, at long last I have a chance to record the last assignment, number 26. We're going to be solving quadratics like x squared using a formula. A formula is when you have letters like, I don't know, a plus b times c equals 2, and I'm going to be replacing those letters with numbers. So let's see what that formula is. First off, I want to remind myself that the parameters of a quadratic equation are a, b, and c. And then what it means to solve a quadratic equation is, just like in algebra, to figure out what values of x will make an equation true. In particular, quadratic equations can have two solutions. So we're used to regular old algebra where if you want to know, I don't know, x plus 5 equals 11, then that means that x would have to be 6. So we're getting a little bit more abstract. Because of this squared term, I can have two possible different values of x that'll solve this equation. All right? And instead of factoring, we're going to use a formula, and here is that formula. It is negative b plus or minus, and this is new. It could be first either plus or it could be minus, a new symbol for you. The square root of b squared minus 4 times a times c over 2 times a. And my strategy is going to be to focus on just this term inside first, and then plug in everything else once I know this term. Now this yellow term has a special name. It's called the discriminant. And the only thing that's important though is that there's so many calculations to do, the square and the 4 times the a times the c, that there's enough calculations to do that I'm going to just do that separately, and then I should be able to keep things a little bit more organized that way. All right, so problem number 1. The quadratic formula has to be solved for 0. So there are occasions, like the next one, it won't be 0 already. We'll have to move things around, but this one's already ready for us. In other words, one side of this equation is already equal to 0, so I can just copy it down again. And then let me clear out some space. You're going to put what I put right here, but I would have to write too small for you to see if I was doing it that way. All right, let's identify a, b, and c, and you put it right there. A is 1, the number in front. B, the number in the middle, is 6. And C, the number at the end in the trinomial, is 5. All right? And now I can identify some things about this parabola already. Just read it straight off. I know that A is positive, so go ahead and circle the word positive. And that means that the parabola has to open upward. I know that a is exactly 1, it's exactly equal to 1, so it's not more than 1 or less than 1, so it's just a normal parabola. It's not a wide or it's not a narrow. So it's just right, if you like. And then c is 5, so that's positive, and that means that it gets shifted up from the origin. All right, so now we're ready. Remember that in the equation, negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. In that formula, the thing that I'm going to do first is the discriminant, b squared minus 4 times a times c. And I'm just going to do that all by itself. So let's identify what each one of those terms is going to be that I'm replacing. B here, whoops. B is 6, so 6 goes right here. I'm about to replace B with 6. A is 1, so I'm about to replace A with the number 1. And C is 5, and I'm about to replace C with 5. So the expression I'm about to have is 6 squared minus 4 times 1 times 5. Whoops. All right, so let's go ahead and do that. So I'm going to replace the B in B squared with the number 6. So it's now 6 squared minus 4 times, and I'm going to replace a with 1. So it's 4 times 1 times c is 5. So that's 6 squared minus 4 times 1 times 5. And probably the easiest way to deal with that is going to be to put it into a calculator, or at least it's an option. 6 squared minus 4 times 1 times 5. Now that's 36 minus 4 times 5 is 20. So 36 minus 20 is 16. And that's called the discriminant. I just figured out what's going just in this part of the square root. And you can see there was already enough in that part of the formula to deal with. I get 16. 16. So this was equal to 16. And I'm ready now to put that into this part and go ahead and write my final formula. So I'm going to put a line here, and I'm going to put another line here. Okay, so let's finish evaluating. I'm going to replace b with 6, so it's negative 6 plus or minus the square root of, and then 16 is what I got from all these terms, 16, divided by, and then 2 times a, well, a is 1, so that's 2 times 1 is 2. All right, and then put a box around your answer because those are the two solutions. When you get into Algebra 2, you'll probably start talking about how to evaluate those two things. All right, moving on to the next question. Okay, so same thing as last time, except in this occasion, this equation is not already solved for 0, so I have a little bit of work in front of me. I'm going to need to move this 4 to the other side in order to get this all by itself. So I do that by subtracting 4. And then this negative 4, I can't combine it with this x, and I can't combine it with the x squared, so I just have to put it by itself. So I now have this side solved for 0, 3x, 5x squared, and this is minus 4 when I move it to the other side. And then there's one other detail, which is that in the quadratic equation, I'm going to flip back. In the parameter of the quadratic equation, the x squared term comes first, and then the x term, and then the term by itself. And so if I want to just read it off, I can see that the x squared term is in the wrong spot. So it should be 5x squared. I'm just going to move it so that it's in the front. And then I'm going to put the 3x, and then I'm going to put the minus 4. All right, and now I'm ready to read off my a, b, and c. So A is the number in front here, it's 5. B is in the middle, it's 3. And C is negative 4. And then in the equation, I'm going to evaluate, A is positive, so this is an upward facing parabola. It's more than 1, and that means this is going to be narrower than usual. And C is negative, so that means my parabola is going to be moved down from the origin. Okay, now we're ready. So in b squared, let me pause for a second. So in b squared minus 4, this is only part of the quadratic formula, but it's the part I'm going to focus on first. I'm going to replace the b with 3. So it's 3 squared minus 4 times, I'm going to replace the a with 5, times, go ahead, Nadia, times c, and c is negative 4. And that's going to be 9 minus 20 times 4 is 80, so it winds up being 9 plus 80. But let's use a calculator, can possibly do that. 3 squared minus 4, times 5 times negative 4. All right, so I've just put b here, and then this was 4 times a was 5, times c was negative 4. And I get 89. So that's the thing that's going inside the square root in my formula, and I did it separately because it was so complicated. So now I'm ready to do the rest of the formula. In negative b plus or minus the square root of, I'm going to go ahead and put 89 here because that's already done, over 2 times a. B was 3, so it's negative 3 plus or minus the square root of 89 over 2 times a was 5. Now 2 times 5 is 10. I could have done that in my head probably. Over 10. All right, so the two solutions according to the quadratic formula are negative 3 plus the square root of 89 over 10 and negative 3 minus the square root of 89 over 10. Let me estimate that. The closest square root to 89 is 81, so that's 9. So it would be negative 3 plus 9 over 10 and negative 3 minus 9 over 10. And let's continue estimating. So that's 6 over 10, that's about half. And then this is negative 12 over 10. That's approximately negative 1. So my two roots for this guy are going to be somewhere around here and somewhere around here. And I've got a positive facing parabola, something like that. All right, I got two more. The thing that you need is this guy here. And the way that I did that was by replacing a, b, and c into the quadratic formula. And we have two more examples.